So this is Station 5 pedigrees. Pedigrees are like a genetic family tree, and the key to being able to read a pedigree is to know what the symbols stand for. You'll see at the top of our paper that we have a key. This key is going to help us to read our pedigree. From this key, I can see that circles stand for females. And there are two kinds of circles in my pedigree. There are circles that are shaded. Those are affected females, females that have the trait. And then there are circles that are not shaded. Those are unaffected females, females that don't have the trait. If I look over here, I see that squares in my pedigree stand for males. And again, there's two types of males. Unaffected males will not be shaded. They don't have the trait. Shaded males are affected. So now I'm ready to dive in and start trying to solve my first pedigree problem. So it says the following pedigree shows the inheritance of cystic fibrosis in a family. So our first question says, how many females are in this family? And I know from my key that the symbol for female is a circle. And because it doesn't specify if it has to be a female who is affected or unaffected, I'm going to count all the circles. So looking over here, I see that there are 1, 2, 3 circles in my pedigree, which means that there are 3 females in this family. The next question asks how many males are in this family. And again, if I look up at my key, I see that the symbol for male is a square. And again, because it doesn't specify if it has to be affected or unaffected, I'm going to count all of the squares in my pedigree, which in this case is just 1. Now the next question says how many affected males are in this family. So now I'm looking for only the squares that are shaded in. Well, if I look over at my pedigree, I don't see any squares that are shaded in. So the answer to this question is going to be 0. There are no males who are affected. This question says the following pedigree shows the inheritance of dwarfism in a family. My first question asks me how many males in this family are dwarfs. Because dwarfism is the trait, to be a dwarf means that you are affected. And if I look up at my key, I know that affected is shaded in, male means square, so I'm looking for the squares that are shaded in. So if I look over at my pedigree, there are 1, 2, 3 squares that are shaded in. So the answer to this question is going to be 3. Number 2 says how many females in this family are unaffected, are not dwarfs. So again, if I look up at my key, I know that females who are unaffected have a circle that is not shaded in. And if I look at my pedigree, I see only 1 circle that isn't shaded in. So the answer to this question will be 1. So question 3 says, is dwarfism a dominant or recessive trait? How do you know? So to answer this question, I have to think about what do I already know about dominant and recessive traits from our genetics unit. I know that dominant traits tend to appear in every generation because remember, to be dominant means that that gene is stronger. So usually if the parents have it, the kids are going to have it. I know that recessive traits, on the other hand, tend to skip generations. That's because, remember, recessive traits are weaker. So a lot of times they'll kind of hide out and then reappear in the grandkids or the great-grandkids. When I look at this pedigree, I see that this trait is in every generation. Both parents have it and most of the kids have it. So I'm thinking to myself, this is probably a strong gene. This is probably a dominant gene. And I'm going to write for my reason because it appears in every generation. Okay, now I'm ready to scroll down to my next question. This question says the following pedigree shows the inheritance of Tay-Sachs disease in a family. My first question says how many females are in this family? Again, it doesn't specify shaded or unshaded, so I am just looking for any circle that's in my pedigree. And if I go over and count, I see that there are 1, 2, 3, 4 females total in this family. So that's going to be the answer to the first question. Number 2 says how many affected females are in this family. So now I'm looking only for the circles that are shaded in. Well, if I look at this pedigree, I don't see any circles that are shaded in. So the answer to this question is going to be 0. There are not any females in this family that have the disease. Number 3 says, how many males with Tay-Sachs disease are in this family? Again, I'm thinking to myself, male means square, and if they have Tay-Sachs disease, they should be shaded in. So I'm looking for the squares that are shaded in. If I look at my pedigree, I see that there is just one square that's shaded in. So there is only one male with Tay-Sachs in this family. Number 4 says, is Tay-Sachs disease dominant or recessive? So again, I'm going to use the same logic I used in the last question. I noticed that in this pedigree, there are not very many people who are shaded in. And this disease seems to skip generations. Neither of these parents has the disease, but the kid does have it. So that to me sounds like a weaker gene. That's going to be a recessive gene. And for how do I know? I'm going to say because it skips generations. Now I've got some bonus questions to answer, and I know I need those points for my biology grade. So I'm going to go ahead and scroll down and try and answer those bonus questions right now. So bonus number 1 says, what is individual A's genotype? So I'm thinking to myself, individual A is shaded in, which means that they are affected, which means that in this case they have Tay-Sachs disease. So in order to have Tay-Sachs disease, what would have to be their alleles? They can't have any big T's or they would be normal. So individual A's genotype must be little t, little t. And I'm going to go ahead and write that on my pedigree. Now the next bonus question is even more challenging. It says, what is individual B's genotype? So for this, I need to think about what I already know about individual B's kid. I know that individual B had a child who was little t, and this kid had to get one of those little t's from dad and one of those little t's from mom. Now, the other thing that I know about individual B is that they are not shaded in, which means that they don't have Tay-Sachs disease. So they must have at least one little t, but they also need to have one big T so that they do not have Tay-Sachs. So individual B's genotype must be big T, little t.